I'm going to talk about flat earth theory in this video and why I don't believe it's so. Now, if this video gets enough likes, I'm going to go through and design and build a big enough antenna to demonstrate what I'm talking about. So more and more people believe that the earth is flat. Well, science shows that it's a sphere. So what gives? So there's a couple of reasons for this. First one is the interpretation of the Bible verses from the original Hebrew and Greek languages. So those words may have other slight differences in meaning, and so people are picking alternative meanings rather than what would normally make more sense. The other reason that people believe that the earth is flat is because of the idea that mankind never set foot on the moon, and so NASA's lost all credibility. Now, this is a problem where there's a mixture of truth and lies in it. So I don't believe that we set foot on the moon either. So the first photo there you see at the top is a film studio where they're depicting the moon landing. Now, why would they have to resort to filming the moon landing here on Earth and faking it in a studio? Well, the problem is that if they try and fly into outer space, there's got radiation there that'll fry them to a crisp. Now, that bottom picture there is what I'm talking about. And also, that comes from the website flatearth.ws, which I recommend checking out. So moon landing hoax, basically, if you can't make it, fake it. So there's problems with the moon landing video and photos, flag flapping in the wind when there is no atmosphere, shadows cast in all directions like it's a lighting studio, problems with the photos, so multiple layers rather than a simple photo, questions to the integrity of the equipment, and more. Now I'll talk about radio signal basics. So as you know, radio signals come in various frequencies from low to high, and so shortwave radio and high frequency band will bounce off the sky and travel around the world. So you could get a shortwave radio and pick up a radio station from halfway around the world, no problems, normally of a night time. The higher you go in frequency, so FM radio stations, for example, VHF band, those signals don't bounce off the sky because they're too fast for it. Likewise with TV stations. If you have a look in that diagram at the bottom there, you'll see what I'm talking about. So UHF is like your TV and mobile phone signals. VHF is your FM radio stations and larger city TV stations. How far can you travel before you lose a radio station? Typically about 100 to 150 kilometres or 60 to 90 miles. So if you drive too far, you lose the radio station, you have to listen to something else. Now, could you design a bigger antenna and pick up those stations from further away? Maybe. The signal won't travel any further because of the curvature of the Earth. So can you build a bigger antenna? Yes, it's possible. There's computer programs out there, you enter some details and it gives you the results. So a basic antenna will pick up 100 kilometres. So you see here the output result is expressed in gain, how strong the antenna is. So if you build an antenna that's strong enough, you'd be able to pick up from thousands of kilometres away. So 21 decibel gain will give you about 128 times the distance. So you go off that 100 kilometre one, you've got about 12,800 kilometre range. So Brisbane, Australia to Auckland, New Zealand is about 2,300 kilometres. So a 15 decibel antenna is plenty enough to do it. But we could go bigger and build the 18 or the 21. If the Earth is flat, that antenna should be able to pick up the radio station no problems. So the challenge is, I've got the technical expertise, experiences and resources to build a large enough Yagi antenna to prove my point. If the video goes viral, I'm happy to follow through with this and post my demonstration videos here. So as we know, solar energy modelling, radio waves and Planet X theories also only work on a spherical Earth theory.